my slides. Just to confirm, you guys can see my slides?
Yep.
Cool. Okay. Let me get slides. Cool. So today I'm going to talk about one of the new Presto query gateway we have built. We call it Odin. So today our agenda would be, we'll talk a little bit shortly about Twilio, current data scale at Twilio, which we're going to talk about some of the stats, like how many queries and all those kind of things we're running in. Why we need this new gateway. We'll say that, okay, why can't we extend the Presto query engine itself having this issue of gateway? Then we'll look at the old state at Twilio, how we're operating and what is the new desired state with this gateway. Some of the design choices we have made. And then we'll discuss in a very high level design of the gateway, how we have done things around. And then we'll look into some of the scaling things we have done for Odin to be very super performant, and challenges, and then future work. And feel free to ask questions around that. Let me know, probably Ali gonna be moderating that. So feel free to ask questions around, it'd be good to have like a very conversation based talk. So let's jump into Twilio. Twilio is a cloud communication platform. Nowadays, we like to call cloud engagement platform, customer engagement platform. It builds an API for message, voice, emails, and Flex is another product we have as a cloud contact center. If you guys have used WhatsApp and you get like OTP, most probably it will be powered by Twilio. If you use Uber and you get like connected by driver, he's messaging you, most probably it will be powered by Twilio. So Twilio is in that domain, and that's why the compliance and governance is so much important, because they're in communication and they have too much of private data around. Our current scale at Twilio, and I will go from this slide right to left. So first going to the query scale. As of now, the query infrastructure we have set up is used more than 1,500 Twilio users on a monthly basis. Sometimes go to 2,500 people also. They run almost 2.5 million query per month, and it's growing like 37% year-by-year growth. We have more than 5,000 dashboards from Looker and Tableau. We scan almost 86 petabyte of data every month. As we move this way, we can see the Presto cluster provisions we have. We have 3 to 4 clusters with the various sizes from 100 node to 25 or like even 50 nodes. And this is the minimum like number of hosts we're running, 180 plus, but it kind of auto scale to almost like twice or thrice size. So it can go up to 400, 500 nodes also. The month end and the quarter end is very heavily used. We are very much, Twilio is very much AWS. So the instance type you see here, that's an AWS, this one. So we use R516X large for coordinators. Workers are for the business critical applications and all that, we run 12X large. For other applications, we use 8X large or 5X large instance type. In last 1 year, 2 year, we kind of like looked into other kind of query engines also. And as of now, we are living in the hybrid world, where a lot of things are business critical things are running in Presto as well as in Athena. In Athena, as of now, we are working very closely with AWS team for almost like a year plus. So we have more than 30 plus work groups, and these work groups are somewhere mimicking the Presto resource groups kind of concept and trying to keep the user groups separate, and so that we can manage them, configure them separately. And it also uses the combination of on-demand plus provision capacity. As of now, we have 3,000 plus TPU reserved for that. Coming back to data lake storage and loaders, this is a little bit old numbers. I didn't get the current one, so I'm kind of setting the old numbers. Sorry for that. I'm pretty sure it has grown a lot, maybe almost twice around. But that old number was around 12 petabyte plus we have in data lake, and we have all the kind of different kind of data format. Different teams based on their use cases go either they use Iceberg, Delta, Hoodie, Parquet, and just on kind of things. And at the same time, we have new transform data also, which you call it data warehouse kind of things, which is close to 3 petabyte. We have their Hoodie and Parquet data. We have more than 3,000 raw data sets, and then we have more than 500 transform data sets, which has been created with the joining and other kind of the business need around. So like talking around why we need a new gateway. So some of the concerns we had initially, if you can see the diagram in the right side, you can see the user were directly using the different kind of these query engines. and they were very tightly coupled. So they were tightly coupled in the means they know the DNS of the cluster and they kind of hitting that and running the query. The problem with that is that if you do any kind of maintenance activity, so then they will get disrupted. So if I kind of like our team is maintaining the Presto cluster one, they may get impacted for an hour or something like that, and that similar thing happened with others. So that was one of the problem we have seen. So we wanted to like address that. Second problem we have seen with the user behavior is that if their team is working with cluster one DNS, if that is working in a good, this one, every use case they have, they will try to run with Presto Cluster 1, no matter what the use case, maybe it's business critical event. So it's a go ideally to different cluster, but by human tendency, we just go with high inertia, we keep going to the same clusters. And over the time, we start to have a lot of problems. So that's one thing. Other thing also, we found out that we run multiple clusters and all that, and we see that load is not balanced. Sometimes the month in, people are bombarding like one of the cluster, but other cluster is sitting there with a lot of the CPU power and memory power there. So we wanted to load balance it also so that we can get the juice as much as possible from all the clusters, and we get the performance what we are paying for. Along with that, as Twilio evolved, we started to use different kind of query engines, and we found that different kind of query engines, everyone has their own ecosystem, and they have different kind of support for authentication and authorization. And it's like it will be hard for the users to go and for one Presto cluster they're using LDAP, for other one Athena they're using something else, for a Spark may they use something else again. And it's a hard as a platform also that how we're going to support all of these platforms. So we wanted something which we can solve by that, maybe have unified them all together. At the same time, as I told, Twilio has a lot of PI data kind of thing. So the governance is pretty heavy. Compliance is a lot of effort in Twilio. So we saw that, okay, we're using Hive Metastore, but this will only support table level access management. We wanted to get to column level as well as particular row level access management also. Though the Apache Ranger does that, but we wanted to have that, the independence to select any tool we want. And as I told, like, because we have a different kind of query engines now, if user want to query Presto, they have to go to one place. If they want to use Athena, they have to go to some other mechanism to do that. Similar with the Spark, they have to go on Jupyter Notebook and run the queries and all that, even if they are running simple Spark SQL and all that. So we wanted to unify all them together and give them one interface so they don't need to switch that much. And at the same time, we looked into outside and we like, okay, what other gateway we can use? We kind of evaluated the Lyft gateway, which is pretty awesome, and others gateway also. But we wanted something which is very modular and extensible, more like a Lego. So if you want to change anything, we can independently take that out and plug that something new around it. So if you look, for example, if it is authentication layer, today we are using LDAP, tomorrow if you want to use Okta or something else, I don't have to rewrite or make sure that rest of the piece is working. It should be very pluggable in that context. Considering all that, we kind of look into, okay, we need a gateway. But at the same time, the question came that, okay, if Athena is maybe supporting, or maybe we are very much AWS, we are going for the lake formation, why can't we add a support in Presto cluster itself or modify the other query engine? Because Athena is closed source, can't do much over there. Whatever is provided is provided. Presto is pluggable engine. You can have authentication, authorization can be added there. But at the same time, Presto is a massive code base. Any changes you require, it will be a good undertaking. At the same time, I believe that every enterprise company has some nuances with its own, something they have that with company culture and the organization and all that. They need something which the other company didn't have, or because of enterprise context particularly, they go in a different way, which may or may not become a general purpose, and we may or may have very hard time to get in the open source. If it doesn't get in open source because of the customization and all that, we'll have to maintain a custom fork for Presto in-house, and that will create a problem in upgrade time now because you have to port now. So every upgrade becomes a massive effort for us. So that's why there are the reasons that, okay, we kind of look into building our own gateway. At the same time, I want to say this was the interesting find. I was kind of like discussing with ChatGPT almost for an hour plus to get some formula where I can get the change effort estimation, and I came with this with help of ChatGPT. Okay. So like alpha, beta, and gamma here is kind of constants and depend on the team and organization, it differs around that. But rest of them, LOC is number of line of code. D is here depending how much transitive dependency it is. M is saying the number of modularity and packages, sub-packages, and A is most like architecture, this one is. So Presto is pretty awesome architecture, you can do that. Somewhere else, this one is. So based on that, like roughly I looked into, say, if we have a line of code of 50,000 plus the modularity and all that is around very like a modest, though the Presto is pretty like a.
Hello, everyone. I hope everyone got here okay.
So it has a lot of dependency and model here, this one. So the value came out is 524, whereas if I look into a small project, which may be gateway or something like we can build around which 5,000 lines code and all this dependency, they came with a 165. And I found this formula to be pretty decent, so I wanted to share with you guys, but feel free to examine and let me know I'm wrong. I didn't depend on any other paper, I was just researching with that around. So you can see here itself, the effort is like almost 3 times low, and Twilio is a company which want to move pretty faster. So we kind of, all these different factors led us to develop a new gateway. Please let me know if anyone has any question.
There is a question, Akash.
Sure.
This is from Yaya. Yaya, how do multiple clusters work together? I mean, how do they distribute the tasks?
That's depend on like, so we tuned it a little differently. Like one of the cluster we say is critical business reporting. So it has pretty massive, the resources like R512X large instances. At the same time, the timeouts and all those factors is pretty large because these are criticals. We run for like an hour, 2 hours is a normal default timeout. At the same time, we identify, like we kind of try to vet the queries which can run here so that the performance and all remain pretty optimal. Similar way, we have Presto cluster 1, kind of this one is more like an ad hoc query. So your tuning as well as the query time mode is pretty stringent. You want to restrict it to keep it like a multi-tenant kind of things. So that's how we have tuned different clusters, and that's where the use cases should go around. We have built a wiki also to decide how it's gonna go around. But it always depends on particular DNS one is using, and that's why we needed a gateway to get that. But otherwise, it's pretty much on the discretion of the person who are using that, whether they're following that guideline or they're just going with whatever their teammates are doing around. Hope that answered the question. Any other, Ali? Move on.
That's it for now. We can keep going.
Good. So going on to the older state. So this was the state prior to the gateway we kind of thinking around. So you can look at here, we have a bunch of tools, Looker, Tableau, DataGrid, Python tools, and all that. They're all using the DNS to go and hit the coordinators. And we had only a few Presto clusters. Each one have their own high metastore locally, but they're all connected by RDS. So they are very consistent across different clusters. And data is residing in S3. And that's how the compute system is working around. But it's all based on the DNS. Going to the desired state, this is what we're looking on. And this is you can see on the left side, we have all the same kind of user set here. But this layer, this is a new layer which we were thinking to introduce. And this layer is supposed to be very pluggable and like extendable. As you can see here, in initial design, we thought about these different modules here. One module is for authentication, which can give us independence to select whatever authentication mechanism we're going to use, LDAP, Okta, and all that. Second one is like pluggable authorization. So as of now, we are very much AWS soft to win for lake formation, but it can be Apache Ranger, or maybe AWS comes with another service, we use that, or something else, open source come up, very awesome thing. We can easily change that and use those kind of things. Caching was pretty interesting. We use different kind of frameworks now, like query processing engines. And different has different behavior in terms of opinion, also in terms of caching. Like Presto has a like query fragment cache, result cache, and everything kind of metadata cache around. Athena has a result cache. You can set up configuration to store your result. But like we wanted to look into this way that, okay, we can extend those or augment them out in the sense that if you're running a query with 4 tables and we again repeat the same query in the next 15 minutes, we can easily check that whether anything had changed in that table. If all those involved tables in that query, if none of them has any incremental change, that means we can return the same result. So those kind of ideas we had that we can build those kind of caches. Similarly, rate limit and all that, we found that different systems have different kind of like a high level control, but none of them have very rate limit. Why the rate limit become important is like if you look at the monthly and all, we have seen the behavior is that an analyst get impatient. He will refresh the looker dashboard, or maybe if he doesn't get the result in 5 minutes, he will run the query again and again. We have seen sometime behind the scene, looker is running like 100 of the queries. So he kind of choke entire his resource group, and his teammates is still for waiting for that. So we want to like have a rate limit kind of things, which is independent of this query engine, so we can control the user behavior and keep it as a multi-tenant system. This one. Query optimization, it's again to augment. All these query engines are already very smart. They're getting smarter day by day, adding more optimization on there. But we wanted to add some custom optimization on top. That simple way is that someone is running select asterisk from this table, limit 100. Now there is no partition info added. There is nothing, this one like metadata added there. Probably we can go and rewrite that query. He's just looking for 10 records. We can add the partition there to make it very streamlined. Similar way, we can rewrite some of the query, like a join order or some other like particular nuances we have in our ecosystem. We can, based on that, we can go and overwrite using the cal site. We didn't do that, but that's the ambitious goal we have there. The query routing, we wanted to build a hybrid kind of query routing system there, which can do both, which can take the hint from user that, okay, this system may work for them. But at the same time, you know how different clusters have been tuned for different use case, and you have the query history. So you can basically model it out and say that, okay, this job which you're trying to run, it's going to run for hour plus. Presto and Athena may not be that good suited for that. Why can't we use the Spark for that? Or something like that. And similar way, maybe you have a different Presto cluster which is tuned for the running those kind of jobs. Okay, so based on those all, the query history, kind of query and operations and all that, you can decide, you make it as intelligent as possible to route them out to different query engines. At the same time, we also feel that the auditing and history around different query engines are different. Presto provide a really nice Presto event listener, which you can do that and capture the events, who is running what. Athena has their own dashboard kind of things. Spark has something else, and maybe like Galaxy and Reno has a little different. So we wanted to unify them all together. So no matter what we use, we have those query history, and this can be used for understanding your users, understanding who is running like a very optimizable query. We are right now using this query history. This is very heavily used in Twilio as of now. We kind of see, okay, who's running what kind of query. Now find out 50 queries, which is the most optimized and scanning most of the data. And like in a group also, we can see that, okay, how much time on average it's taking, how the performance is, how many queries fails over it, with the query failure rate is getting better or not. So all those kind of insights we build on this query history. Currently, we use DynamoDB to store that, and eventually we take that to become another Apache Hudi table for us, and that table is very heavily used. So that was the initial idea of this Odin with this modularity in picture. Cool. So I will go in the design choices here. Any questions so far?
I'll just remind folks, feel free to just drop your questions in the chat if you're on LinkedIn or Zoom, and I'll be monitoring those. I think we can keep moving, Akash.
Cool, thank you. So coming back to design choices, if you look at here, like in previous slide, the older state was that all these users are using Presto drivers to connect over there, and we have more than 1,500 regular users. So we wanted to make sure that we don't cause a disruption, and working with them would be pretty heavy task to work with all of them and move to this one. Ideally, the way it is that I would have preferred to build a new JDBC driver so that we have a lot of independence and we can choose the protocol and all that. But after evaluating the Presto, we found that it's pretty decent. It's very more than decent. It's really well designed. So why can't we leverage the same one to support all these different query engines also? So we keep persisting with Presto, and that way we don't have to work with users to change around. They just need to change the DNS for the new Odin, and that's it. So we wait for that. And Presto internally works, the driver, it works mostly on the HTTP calls, so the REST APIs and all that. So in that context, we use the Netflix Joule, which is another open source layer 7 application gateway to build Odin. What it does provide is it's in Java. So it, like a lot of talent we have, the teams are all very friendly with Java. So we kind of that become natural choice for us. The other one is also that it has been used in other products in Twilio also. So we know that it's going to scale and performance, and it has been tested at Netflix. So we need that it's going to be performant. And the internal architecture of Joule is very well designed. So that's helped us to build a pluggable and extensible component. Like each component there, you can play like a Lego, you can add more items, you can remove the one component and those kind of things. So Joule provides all those like a detail in nice over there and really good architecture around. So we kind of thought like, okay, we'll build Odin on top of that Netflix Joule. The other design choices we also made, like we were using the high meta store for storing all the stable metadata and all that. And we found that as we are growing bigger, there is more ask for entire Twilio to use high wedge service. And that means that we had to build all these nice thing around like rate limiting, making it HA and doing all those kind of things, packaging it out, which may be a massive undertaking. At the same time, connecting with this different like Athena and Spark and all that, we needed to like expose it out and do a lot of security around things, building networking and all, which some of our security team was not happy and they had a concerns around that. So like we decided that, okay, let's move from Metastore to Glue catalog, which is almost Hive compatible engine, most of the teams say. And because we were building an Odin layer, so for authentication and authorization itself, so only we need Metastore. So Glue catalog is kind of widely accepted as standard. Most of the framework of query engine supports it. So we kind of think like, okay, that's and Glue catalog provided a service, so it's going to take care of rest of us. At the same time, we were looking into database initiative in Twilio also, and we found that Glue catalog and with a combination of lake formation will be pretty powerful for implementing that database also. So that's also was another push to move Hive Metastore to Glue catalog. We did in the real time here move from Metastore to Glue catalog, that we didn't cause any disruptions. We did use the Lambda architecture. In some other tech talk, maybe we can talk about how we did the Metastore migrations. The other design choices we had is that we kind of look into a lot of different kind of authorization tools we have in industry right now, Apache Ranger and all that, because we needed a column level permissions as well as a row level access management also. But as I was talking about the data mesh, and Twilio is very much AWS ops, so we kind of had to use something in the AWS build itself, and lake formation fit the bills here. So we kind of used a lake formation as of now for authorization. And because it's a pluggable engine, we can move around, choose something else also as we move forward on that. At the same time, we were looking into, okay, how the user's gonna hint us. Like same way, if you run a DB query, you kind of give the index hinting. We wanted to get some hint from user what their use case looks like. And instead of giving the concept of the DNS, we wanted users to think in terms of use case and add that use case in the hint in the JDBC connection, so we can leverage that fact around that. So we as of now we thought of like running them in hybrid in the sense that some responsibility goes to user to suggest what kind of use case they're gonna be running the query around, and then some of the choices can be made at the server side to see that, okay, whether this is gonna fit the bill or not. And so in that respect, we kind of come up with this grammar here, which is pretty much influenced by the Presto selector, resource group selector algorithms there. So this has, as of now, it suggests that, okay, if user is Akash Pradeep, and if source is whether source means whether he's coming from Looker and all that, and probably this is extensible, so we can add more parameter to select a particular use case and all that. And we built something nice here, which is the fallback system here in terms of query also. So in this case, just to explain you out, final route supposed to be Athena. And then work group, we said that, okay, go to work group 1. That's kind of dedicated for you. Now it's going and see that, okay, work group 1, let's see how much it's used. If we see that, okay, there are more than 6 queries already waiting. So we don't know how long it could. Sorry, anyone have any question? Okay, so if there are more than 6 queries are waiting here, then we don't want to like add more and keep waiting forever. So rather we have a fallback saying that, okay, work group 1 is very busy. And you can do similar with Presto clusters also. If Presto cluster 1 is very busy, you can see alternate Presto clusters, which we can use for this business use case. And if you see that that's available, use that. Otherwise, keep going in fallback mechanism and go to the last one, which is more like that should be your default. Just go and run it there. Okay, no matter whether it's a waiting and all that. So that way we kind of, like we are load balancing at the same time, we kind of making sure that load balancing based on choice in different use cases can go different fallback mechanism and different business user group also based on their criticality and all that. So a lot of the decision making is came to the server, but still some of the choices goes to the user side. So they can dictate it, but eventually everything decision can be made at server side. And using this fallback mechanism, we were making sure that whatever the EC2 cost or the compute cost we are paying around, we are leveraging that. So those were the design choices we made around. Now getting to the gateway design. So gateway design is, so Presto internally is very much heavily aligned with, as I told you in the beginning, like Presto driver uses HTTP to communicate. And they use post and delete. Post mostly it's for running a query. So when you first time you submit a query, it's become a post call. So it has a different flow of Odin internally. It goes through different component to that. When it goes to the get call, so the way Presto works internally, that first it will make a post call. It will run the query. Once it gets the payload says that, okay, it suggests that what URL you can use to get the result. And it in a spill lock mechanism, it keep going and keep asking that, okay, what's the status of the query? What's the status of the query? And when it reaches to the terminal state, it gets the data set, the result set now. So that's the way it operates. And we leverage that fact, and the component here and the designing goes a little different. That's why it's kind of separated out. So if you look at the post call, when someone is running the query, the first thing they're going to hit is load balancer, and we are running multiple instances of Odin here as a web server. So it can hit to any of them. And internally of that, it will go to the first, this is one of the component. And the way this is leveraging the Joule architecture. And the Netflix Joule has a very nice a 3-component system around. One is inbound filter, which is anything you are looking to the query coming in here. Then it goes to the endpoint, which is like your final endpoint where you're reaching out to server and doing some action. And once the action is done, then you get the result, and then you put that in the outbound filter, which is more like a response delivery system. So you can plug your systems anyone you want, like the caching layer and all those can be put in the inbound layer itself. But if you have like a history management, like query history management or something else, you can look into the like response back here. So we leverage that design here, and we have different component, and each one, like these all inbound filters, you can remove and add them as you want based on your configurations. Not at the runtime, but at the compile time, at least you can do that. So you can see here that one of the component is to do the authentication here. As of now, it's used like that, but it can be moved around, and only this required to be changed if you decide to move to some other authentication. Once the authentication is done, it goes to the authorization filter. Authorization now look into your query, try to parse it out and see what you're intended to do, what operation you're looking into, what a query you are, what are the tables you are involved in your query, goes and read this glue data catalog, see that, okay, get all the metadata around the table, use the lake formation to get the tags around that table, and then compare and see that, okay, whether a person who's running that query, he has the enough permission to do these operations on these tables. Okay, and based on that, it makes a choice there, decision over there that, okay, whether it's going to go forward or it's going to do the authorization exception here. If it all looks good, it goes to the next layer, which is router layer. Router layer decides that, okay, and each one works independently in their own context so that it become independently replaceable. So the router layer then takes the query and see, okay, where I'm gonna go get it to. Whether it's depend on the query, I can take it to Athena or some other Presto endpoint or maybe Spark around. So based on that, it makes a choice whether to go for. And once it makes the choice, then it goes and does its own job. Like Athena endpoint will go and talk to Athena, get the result, do the protocol translation, and then take it back to the outbound way. And there it's a history service. So if the query is submitted here, history service will go and record that, okay, whether what the state is, what it's like, who ran the query, whatever info you want to capture there, you capture it. Most importantly, it's looking for the query ID and the routing mechanism so that it becomes a stateless kind of things. So which routing mechanism has been used, whether it's Athena or proxy or Presto clusters around. So it stores this data in DynamoDB and moves on response service, and response service return it back to the user. That's how the input of the query submission works. Next time, if the query submission is good, it has been able to successfully submit it, then the Presto driver here in one of them, it will run in a spill log. But for every request, it will keep hitting the load balancer will see that, okay, as a round robin, it will keep distributing across different Odin instances. Each Odin instances again will do the authentication to make sure, because the HTTP call, to make sure that his credentials are valid. If credentials are valid, it will take to the directly routing layer. So you see here, it doesn't require authorization now because it's asking for result, not for the submitting the query. So there is nothing to authorize here. In the router filter, it will go and hit the DynamoDB and say that, oh, this is the query ID you're asking for result and status, where it's got routed to. And based on that, it will route again. And Athena endpoint will do again. It will go and check Athena, or maybe you go to the proxy endpoint, which will say that, okay, this query was meant for Presto cluster 1 or 2, and then it keep hitting that Presto cluster to get the result. And then again, keep on the outbound result if you want to capture the state here, or you just want to be returning the response. So that's how it keep operating around for the post and get calls around. Scaling, so now I will talk about the scaling factor here. So scaling, this one is, so you can see here that so information is mostly persisted in, like, so we wanted to make sure that, like, we made it stateless. And for that respect, we kind of, like everything we are kind of running around, like which routing mechanism has been used, and like a query or everything metadata around, we kind of keep capturing in DynamoDB. And using this metadata layer storing in the DynamoDB can give the independence that the host can go down and or request can reach to any of the Odin instances. So it doesn't need to have a sticky over there that only one should go. Rather, it's become a stateless kind of thing. So you can deploy it easily, as well as you can scale it more as the requirement comes in. So that was one of the design choices we made to make it a stateless and a scalable. The second, the problem we found out as we were running more, that the post, like we are making so much calls around in the post. You can see we are hitting the glue data catalog, getting all the metadata. Then we are hitting the lake formation, getting all the tags, authorization info. Then we're doing the comparison. With every request, we found it out when we're doing that, it has a massive, like multi-service calls in it, and it's add more delay in that. So we wanted to, like, we introduced a lot of cache. A lot of things are influenced by Presto itself, how it does Presto internally, with the caching layer for the Hive and all that. So based on that, we add a lot of caching in this system. And we also realized that, like the caching we used here, this is only used for when the query is submitted. So why don't to separate out two target groups, one target group just for the post calls. So we have 2 or 3 instances running in that target group, and they are running in different AZs to make sure that, like we are mostly HA and all that. And those are heavily back on the cache now, which is only for the authorization layers and all that. The remaining is like the other set of target group is like the get calls, and get calls, because it runs in a spin lock, there are millions and millions of get calls get in. So there is another target group which has a heavy number of instances, 10 plus, and this is also distributed around the edges. And their caching is only with the DynamoDB. So they cache all the metadata in DynamoDB. So if one query is running at the given time, you will have mostly like given hour, you have like 1,000, 2,000 query running. So caching them out enough info is not a big enough deal. So we can easily cache in memory from DynamoDB and then keep using that. So based on the caching and the scaling factor, we decided to put them in separate application load balancer target group, and based on whatever HTTP method call they're coming in, we kind of easily distribute them out. And that's how we easily scale that queries. The other factor also is that we found out that because we are doing the authorization layer in the Odin itself, if we saw query is big enough, like it involves like 5 tables around, we have seen that it's added a latency of 3-4 seconds because it makes so many service calls. Similarly, if a query is large enough, then it sometimes takes around 8 or 9 seconds around also. So we were looking to minimize that, and that's where we kind of introduced a lot of caching for all these metadata from lake formations and all that. We have a periodical job which reads from there and keep storing that in the caching memory cache, similar with glue catalog and all that. And it becomes a little more complicated in multi-account setting, is that it may possible that, a particular query which coming in for a table which lives in some other regions, and you have to go into that region, you have to get that like metadata, and then you have to see that, okay, like first you have to read the tables in from the glue and see that which region, which account it belongs to, and then for the lake formation you have to hit that region to get all this metadata tags info. So it became like multi-call effort and all that. So we kind of introduced a lot of caching there, and because we have a separate target group here, the caching was local to those number of instances only, and it's kind of pretty well rate limited and scalable kind of thing system around. So we added a lot of caching, and then we found that on average, it came down to 10 milliseconds, all this authentication and authorization. In fact, right now, Odin, we run like 100,000 jobs per day, and overall overhead per query around is 6 to 10 millisecond max. Some of the challenges we had, we were like, as I talked about, some of the large query initially was getting timed out with authorization check. So we had to build over the caching and build multiple layer of caching to overcome that. The other problem, which is still kind of this one, is how to parse the query and identify the tables. Some of them, like Presto, has a really nice library, Presto parser. So we use that to parse the query and see that, okay, these are the table the user is running against. So and do the metadata fetching and all that. But like in case of Athena and all that, because a closed source, there's no open source library around. To have to understand that a lot, how Athena is operating around. And we found that it's using behind the scene Trino for DMLs and DDLs using Hive. So we use combination of a union of those two. But it was a little complex to get there. The protocol translation also is a little different because like we are converting everything to Presto now. So some of the like Athena is mostly like the results that they have is different from the Presto. Like all the data is in varchar, but they do have the metadata that this column is float or integer. So we have to do that translation to be in the Presto protocol. So the drivers keep talking in that terms. So that was some of the challenge, particularly for the paginations and different kind of queries, how the result set comes in. Supporting Tableau was the another problem, because Tableau still for Presto uses ODBC, and the UI is pretty old. It's very rigid in sense that there is no way to even like add the one choices we have made earlier is like adding this parameter to decide where the user can give a hint. You cannot add that in Tableau. So we had to add more DNS, more CloudFront kind of things around to overcome that. And it took us some time to understand that all the requests coming from them is like there's no compression enabled over there. And that like impact our performance also, but like, yeah, that's one thing we observed with ODBC Presto layer. It's not compression, so it's byte in, byte out, rather than only the compressed bytes going over the network. So we have seen some latency and added delay over there. We are still looking into that, but yeah, that's like we have to set up a lot in Odin to overcome that problem. The other one, which is in Athena, we kind of, after a lot of experiment, we found it out that if you, in same work group, if you run multiple users are running the prepare statement with same statement name, the results get little like you may get incorrect results on there. So so we found out how to overcome that in that sense. So we say that, okay, if prepare statement is there, always goes to Presto. Similarly, we have found some syntax difference, though Athena is using Trino. Trino and Presto is close, but still there is some difference out there which we have to tackle around. And that become a little challenging with the parsing logic here. So we have to use, like the code has started to get a little complex, but be able to do that. The other challenges we had in terms of, as I was talking about, if your region is different than the current one, then you have to make too many calls. And the understanding that whole part, how you're going to do that, was also, it took some effort to go there. That if you're running in EU West 1, but if your data, which is the table which has been saved from AP Northeast 1. So you have to first make a call to get the metadata from glue and see that, okay, whether this table originally from Northeast 1 or not. And then you may need to make a, you need to assume a role which can call in the Northeast 1, get all this metadata from lake formation, and then do the authorization. So it took us some time to get there. Similarly, we were using lake formation for other purposes also, like S3 access management and all that. Which we can use in the lake formation. That's a really nice feature, but at the same time, it requires another vending API concept so that like the client can see that, okay, a particular S3 is governed by lake formation now, and ask the temporary credentials and all from lake formation, then use that. And this is only supported in some of the AWS services. It's not general purpose available as of now. So I hope someday maybe lake formation team can release S3 library which can be used by the other open source framework also to support that. It's a really nice feature. Because the S3 in general, IAM policy, you cannot do the fine grained control. It's mostly coarse grained. The other problem Presto also have is Presto is only runs with a service role. So no matter who the user or what IAM role you're using, it's always runs in the context of the service role and like access the glue catalog and S3. It would be really nice if we add the concept of runtime IAM role. So whoever is running that, use that, and that will give easiness in like and sit with the governance kind of this one, that the one who's running that is run against that role, and all the governance will be followed around that, rather than using the service role for everything, which we have that in Athena, which really we like that. So that's still a little bit challenge because we want to operate in that way, and we're kind of looking to how to build that also. The other problem with the Joule, we found it out that if you look at here, Joule is proxy endpoint is talking to your coordinator, and the Joule has a feature to cache it out so that they don't do the DNS resolution again and again. So what they do is against this DNS one, they will cache the private IP of coordinator so they can keep talking to that. But in the meantime, if you redeploy the coordinator and you got a new private IP, it takes it takes some time for Joule to identify that and then like change that. And we found it hard way. We found a problem in production. So, but Joule at the same time provide that pluggable engine, extensible engine also. So one of engineer in my team went ahead and you kind of added that code over there that they can do the DNS resolution pretty often and get the private IP which has changed with the redeployment of the Presto cluster. Yeah, that's pretty much the challenges we can we had. The future work we are looking for is adding support of Okta Entity Center for authorization, which gives us okay, we can use some of the nice things that Entity Center has for per user kind of context matching, as well as the auditing get much better in that context. So we want to go there. Hope someday the Presto also supports it natively. As of now, we have established a parity, though we use lake formation, but we haven't gone to column and row level access management. We want to go there. That's not like that big challenge. It's just like we need to improve the Odin to go there. Similar way, we want to add a support for Spark, though I talked about that we can use the Spark for many things around, but we haven't gone there. We need to add that adapter library and all that. So we have to extend that. As of now, we just work for 2 quarters and Odin is in production, but we want to enhance that to support the Spark also. And the one which is long list for me is like adding the AI for routing selection, a smart, intelligent way to do that. If you look at the initial design we had, is a routing layer here. Initially, just getting a hint and defining some grammar, it will be awesome if we can, we can make it so intelligent that based on the query history, it can see that, okay, where the query can go and what kind of query engines we can use, what kind of Presto clusters we can use for this particular query, and do the routing around that. So that's where the state we want to take it. So those are some of the future work we have kind of looking into. Please let me know if any questions around.
Awesome. This was a really great presentation. Thank you so much, Akash. We do have several questions. I'll just remind folks, if you do questions, drop them in the chats, whatever platform you're on. So somebody asks, any plans or thoughts on perhaps open sourcing Odin?
Yeah, I'm looking for that. So, like, probably I would like to get some feedback. If people are interested, please post on the
Oh.
LinkedIn or let me know. I cannot promise it, but I'm gonna work with this is one of the desired item. Also, I have future work that I put in open source.
Awesome. Super cool. Somebody asks, okay, sorry, I might have missed this at the beginning. How does Odin manage query performance across all the engines you're using? Presto, Athena, Spark, are there specific optimizations in place depending on the engine?
We have done some work around that, but it's very much isolated to the Twilio users in that context and what kind of tables we have. So we have added this kind of query like routing selections based on the particular user group that's saying that, okay, they are more business critical, or they are kind of doing the ad hoc. Like in this case, for just an example's sake, if I say that Akash Pradeep is always coming with data grid, probably you won't use the data grid for production use case. Mostly you will use for exploration. So in that case, you can route it to take it to the some, like maybe Presto cluster, which is little cheaper, lower instances, or maybe take to the on demand and do that. So that kind of work we have done. But we didn't add a lot of intelligence on fly to dynamically select that, like this kind of query can go there. We are looking into that, we can do the explain plan, try to understand how much expensive these queries and based on do routing, but that's something in future work kind of things.
Cool. Are there any metrics that you can share on some of the performance improvements or operational improvements you've seen since deploying Odin?
Yeah, I should have. I don't have somehow, but I can post out on the LinkedIn later on. As I was telling out, we kind of did a lot of the enhancement there in Odin itself. So overhead is almost less than 10 milliseconds. But because of the different query engines, we are also seeing using Athena for a lot of use cases. They're giving much better performance. At the same time, some use case goes to Presto and give much better performance. So I can say that. But that was an interesting take around here.
Yeah, cool. Any AI gen integrated with the platform?
That's my wish list. I hope someday, at least for the query routing, we have that, as well as for the query optimization. We can leverage that, and probably that's where if I do the open source, probably I can get contribution from other people also, which they can add around. I feel that there is a lot of a scope there to add the intelligence system here and make things work better for us. But as of now, we haven't added anything.
Cool. All right, let me check my last. I think we have answered everything. So with that, I will say, Akash, thank you so much. I know Twilio has been using Presto for quite some time now, at least a few years. And so it's been really great to see the evolution and how, all the innovative work you're doing with Presto. I hope that you come back in like 6 months and tell us the next great thing and how it's growing at Twilio. It's really awesome to see, how the platform grows and how Presto grows with it. So thank you so much for your
Sure, we'd love to
time.
be.
Yeah, and sharing your use case. It's really great. I will just drop one more time, PrestoCon Day. I'll drop the link in the chat. Please join us. It's June 11th. It's virtual. It's like worldwide. And it'll be a great place to learn more about more users like Twilio, and what they're doing with Presto and what's going on with the project. All right. Thank you again, Akash.
Thank
This
you,
is
everyone.
awesome. Thanks everyone for joining, and we'll see you next time. Cheers.
Thank you. Bye-bye.